Hello. Today we're going to review or learn how to solve compound inequalities in notes 9. So these are notes 10. Sorry, I'll slow down. In notes 9, we learned how to graph compound inequalities, and today we're going to learn how to solve them. So this is review from the last notes 9. If you need more details, go look at notes 9. But we learned what a disjunction was. A disjunction were two inequalities connected with the word or, and their graphs graph away. The two graphs go away from each other, so they go out. A disjunction is always graphed like this. If we have two numbers, it's an either open or close, but they're shaded away from one another. Disjunctions all look like that. Conjunctions use the word and they're graphed towards one another, so the graphs connect in the middle. All conjunctions look like this. If we have 3 and 10, it's the set of numbers between the two inequalities, and then the disjunction is the set of numbers away, outside. And then to solve them today, we're going to learn how to solve them. To solve them, you're going to solve each inequality separately and then just graph them. This should be pretty self-explanatory. So this is an example. The issue here is we have two separate inequalities to solve. We're going to solve this one and solve this one, and then we're going to put the word or in between, and that's going to be our answer. So we're going to draw a line through this inequality. We're going to totally ignore this one. We're just looking at this problem. My goal always is to get the x by itself. To get the x by itself, I'm going to take away 9 from both sides. Take away 9. Take away 9. X and 15 minus 9 is 6. And then I didn't divide by negative or multiply by negative, so my inequality symbol comes straight down. So that's half of my answer. That's half. I now have to solve this one. Draw a line through the inequality symbol. My goal is to get this x by itself. We're ignoring this. We're just solving this one-step inequality. So I'm going to add 3 to both sides. And the inequality symbol I'm just going to copy down because I didn't multiply or divide by a negative. So now I have my two inequalities. Now I'm going to rewrite it. X has to be less than 6 or x has to be greater than or equal to 13. This is our solved inequality. If we wanted to graph it, we could. We would go to 6. It's an open circle because it's not underlined. The numbers smaller than 6 are all of these numbers. This is underlined, so it's a closed circle at 13, and it's all the numbers bigger than 13. So we go that way. Notice it was connected by the word or in the original problem, and the two inequalities are facing away from one another, which is what I would have expected from a disjunction. For the next one, we're going to do everything the same. We're going to totally ignore this one, solve this inequality, then ignore this one and solve this one, and then just put the word and in the middle. At the end, it's and because that's what it starts with. So line, this is a times 3, so we're going to divide by 3. X is less than or equal to negative 3. Even though my answer is negative, the number I divided both sides by, this number right here, is positive, and so I don't flip the sign. Some students get confused that if the answer is negative, they want to always flip it. That's not true. We only flip it when we divide by negative. So that's half of my work. For the other one, I'm going to take away 7. So now I've solved my two inequalities, and then to finish it, I just write the word and in the middle. X is greater than or equal to negative 3, and x is less than or equal to 3. That's my answer. If you want to check your work, graphing it is a great way to check your work because we know if it's connected by the word and, we would predict that the two graphs would be facing towards each other. And if our graph ends up looking funny, then maybe we solved it wrong. But here's negative 3. Here's 3. It's a closed circle at both because they're both underlined. X is bigger than 3 are all these numbers, negative 3. X is less than 3 are all these guys. So this is correct. That's what we would have expected a conjunction to look like.